Hello, this is Keith Caballero from K-Dawg Weather. Today I'm going to do a PowerPoint presentation of the science of lightning, from charged clouds to striking ground. What is lightning? Lightning is a massive electrostatic discharge between charged regions with a cloud between clouds or between a cloud and the ground. It occurs when electrical potential differences exceed the insulating capacity of air, roughly 3 million volts per meter. The resulting discharge heats the surrounding air to approximately 30,000 degrees Celsius or 54,000 degrees Fahrenheit, 5 times hotter than the surface of the sun. More than 44 flashes per second globally, 1.4 billion flashes per year, 30,000 degrees Celsius air temperature in channel. How lightning is formed. Charge separation in thunderclouds. Collision and charging. Ice crystals and hail collide inside a cumulonimbus cloud. Lighter ice crystals gain positive charge. Heavier hail gains negative charge. Charge separation. Updrafts carry positive ice crystals to the cloud top. Gravity pulls negative hail particles to the lower region, creating a giant dipole. Electric field buildup. The potential difference between regions can reach tens to hundreds of millions of volts, eventually exceeding air's insulating capacity. The lightning flash. Stepped leaders and return strokes. 1. Steeped leader. An invisible channel of negative charge zigzags downwards in more than 50-meter segments, creating a forked path towards the ground. 2. Streamers rise. As the leaders near the ground, 100 meters positive, streamers reach upwards from tall objects, trees, buildings, and poles. Number 3. Connection. When leader and streamer connect, a powerful electric circuit is completed in less than a blink of an eye. Number 4. Return stroke. A brilliant surge of current races upwards at 100,000 kilometers, producing the visible flash, can reach 30,000 amps. Lightning by the numbers. 3 million volts. Potential differences in a typical lightning discharge. 30,000 amps. Average current in a return stroke. 100,000 kilometers a second is the speed of the return stroke traveling upward. 30,000 degrees Celsius is the temperature of the lightning channel. 1 to 2 inches is the actual diameter of the lightning channel. Greater than 1 second total duration of complete flash. Types of lightning. Cloud to ground or CG. Negative CG. Most common type is 90%. A negative steep ladder descends from the cloud, triggering a positive return stroke from the ground. It produces the classic branching pattern. Positive CG. Less frequent but significantly more powerful, often occurs in supercell thunderstorms known for longer duration, brighter flashes, and louder thunder. Intra-cloud and cloud to cloud. Intracloud, the most common type, occurs entirely within a single thunderstorm cloud, discharging between regions of opposite charge. Accounts for the vast majority of all lightning flashes, 5 to 10 times more frequent than cloud-to-ground strikes. Often sees as a diffuse glow illuminating the cloud within, commonly called sheet lightning or heat lightning. Cloud to cloud, intercloud discharges. Occurs between two separate storm clouds, traveling across greater horizontal distances in the atmosphere. It can produce dramatic visible streaks extending horizontally across the sky, sometimes spanning several kilometers. Together with icy lightning, these non-ground flashes make up approximately 75 to 80% of all lightning activity on Earth. Ball lightning, a rare mysterious phenomenon. Ball lightning appears as a glowing spear typically 10 to 40 centimeters in diameter, often or during after thunderstorms. Color ranges from red and orange to white and blue. It may last several seconds to over a minute, or longer than a normal flash. It moves unpredictably, hovering, bouncing, or drifting through rooms. It has been observed passing through windows and walls. Leading theory. Lightning strike silicon-rich soil creates a cloud of reactive nanoparticles that glow as they slowly oxidize in the air. Above the storm. Sprites, blue jets, and elves. Sprites. A massive reddish jellyfish-shaped glows extended 50 to 90 kilometers above powerful storms. First captured on video in 1989. They are triggered by positive CG flashes. Blue jets. Cone-shaped blue discharges shooting upwards from cloud tops at speeds of 100 kilometers a second. They reach altitudes about 40 to 50 kilometers above the storm. Elves. Expanding rings of faint light at 90 kilometer altitude. Lasting less than a millisecond, caused by electromagnetic pulses from intense lightning strokes. Global lightning distribution. Lake Maracaibo, Venezuela. 297 lightning days a year. Up to 28 flashes a minute, called Lighthouse of Marabaraco by colonial sailors. Congo Basin, Central Africa. 158 flashes kilometers square a year. Among the most lightning active regions globally due to the intense solar heating. Tropical region. 70% of all lightning. Nearly 90% of strikes occur over land in the tropics where warm, moist air masses meet. Lightning and climate change. 12% increase in lightning activity for every 1 degree Celsius of warming. 12 to 14% rise in global lightning activities over the past 30 years. 3 billion plus total lightning strikes on Earth annually and growing. Warmer air holds more water vapor, fueling more intense thunderstorms, increasing lightning frequencies worldwide. Scientific studies project that lightning activity will continue to accelerate as global temperature rise. This has direct consequences. More wildfires, lightning is a leading ignition source, increased infrastructure damage, and heightened risk to outdoor workers and communities in lightning-prone regions. Lightning safety. When thunder roars, goes indoors. The 30-30 rule. Seek shelter when the flash of thunder gap is 30 seconds or less. Wait 30 minutes after the last thunder before going outside. Best shelter. A fully enclosed building with wiring and plumbing offers the best protection. Also, avoid open structures like picnic shelters or gazebos. Indoor safety. Stay away from water, plumbing, and ported electronics. Lightning can travel through a building's electrical and plumbing system. Outdoor emergency. If caught outside, avoid tall objects, open fields, and bodies of water. Never shelter under isolated trees. Nature's most powerful electrical phenomenon. Lightning connects our atmosphere with the ground in milliseconds, releasing more energy than a nuclear power plant in an instant. This is Keith Capillero with K-Dawg Weather. Thank you very much for the PowerPoint presentation. Let me do this PowerPoint presentation. Please like and subscribe and give a thumbs up to this channel. Thank you.